Alright, this video is over section 4.6, radical equations and equations with rational exponents. So first off, a radical equation is an equation with one or more radicals containing a variable. So an example would be like the square root of x, and this is in a previous, you should have this as a previous knowledge, but that is equal to x to the 1/2. And then similarly, just so you can see it, if I have like x to the 3/2, that would be the same thing as the square root of x cubed. So you can use that as a reference if you need it, but that should be prior knowledge. And then again, extraneous solutions should be prior knowledge too, but that is a potential solution. That does not check. So you get your solution, but when you check it, it actually doesn't work in the original problem. Okay, we're going to solve these next problems and then we're going to check them for extraneous solutions. So we have the square root of x minus 13 equals -10. So the first thing I'm going to do is isolate the square root. So I'm going to do that by adding 13. And I'm going to get the square root of x is equal to 3. Next, the inverse of the square root is squared. So I'm going to square both sides. And that's going to leave me with x equals 9. Now to check that, I'm going to plug in 9. And when I do that, I'm going to have the square root of 9 minus 13 equals -10. And I'm going to put a little question mark here because I'm just not sure. The square root of 9 is 3, so I have 3 minus 13 equals -10, and that does check out. So our solution set for this one would be 9. All right, for this next problem, we have the cube root of t plus 1 plus 6 equals 9. So the first thing I want to do is get the square root by itself, so I need to get rid of the 6. So I'm going to subtract 6, and I'm going to get the cube root of t plus 1 is equal to 3. The inverse of cube root would be cubing, so I'm going to cube both sides, and that leaves me with t plus 1. And then 3 cubed is 3 times 3 times 3, which is 27. I'm going to subtract 1, and I'm going to get t equals 26. We want to check to make sure that 26 is not an extraneous solution. So we're going to have the cube root of 26 plus 1 plus 6 equals 9 with a question mark because we're not sure if it's going to work or not. So we have the cube root of 27 plus 6 equals 9. Again, not sure yet. And the cube root of 27 is 3. So we have 3 plus 6 equals 9. And now we can say, okay, it does check out. All right, for this next problem, we have 3 equals 6 plus x minus 1 to the 1/4. And remember, that is the same thing as the 4th root of x minus 1. So just so you can see that, this is the same thing as that. I'm going to erase that so I have space, but just so you know for your notes, if whichever way makes more sense for you, those are the same. Okay, let's see. All right, so I want to get that radical or rational exponent by itself. So I'm going to subtract 6 to start. And that's going to leave me with -3 equals x minus 1 to the 4th. And to get rid of the 4th, we're going to take it to the 4th power. And kind of like a cheat if you think about it. If you have 1/4 times 4, that equals 1. And so that's kind of why taking it to the 4th power cancels it out. Okay, so when I do that, -3 to the 4th power is +81. And then on the right side, we're left with x minus 1. I'm going to add 1, and I get a solution of 82. We need to make sure that it's not extraneous, so I'm going to check it. And when I check, I'm going to have 3 equals 6 plus 82 minus 1 to the 1/4. And I'm going to put a question mark because I'm checking. I don't know yet. So now I have 3 equals 6 plus 81 to the 1/4. Checking it again, I'm not sure. I end up getting 3 equals 6 plus, and then the 4th root of 81 is 3. So this does not work. 3 is not equal to 9. And so that means that this is an extraneous solution. So if I were to ask what the solution set for this problem was, it would be the empty set. And how we write that is, there's a few different ways, but for this class, we're just writing it as empty brackets. So I'm going to write empty set is how you would say it. In other classes, you might see this symbol. That also means empty set. You might see no solution too. But for the class I'm teaching right now, it would be these brackets, just empty. All right, next problem, we've got 2 times x minus 4 to the 3/4 is equal to 54. So I need to get these parentheses by themselves, and at this problem, I left it as 1/4. For this problem, I'm going to switch it into the, I guess, radical form so you can kind of see what that looks like too. So I'm going to divide by 2, and then I'll switch it to the radical form so you can see. So these cancel out, and when you take something to the 3/4, the 4th root will be on the outside, and then the cube root would be on the inside. So what that would look like would be a 4th root, and then x minus 4 cubed would be on the inside of that. You could write it, technically, how would you write it? You could write it as a 4th root cubed like that, so opposite. It just looks a little nicer, and you'll see it more like the way that I wrote it. But it doesn't matter if you do the 4th root or the cube root first. Okay, and then 54 divided by 2 is 27. So now the 4th root's on the outside, so we're going to take everything to the 4th power to get rid of that. And I'm left with x minus 4 cubed equals 27 to the 4th is a huge number. It is, I had to type this in earlier, 531,441. And to get rid of the cubed, we cube root both sides. Again, I'm using my calculator. I am not doing this in my head. And I'm left with x minus 4 is equal to, the cube root of that ends up being 81. I'm going to add 4. And my potential solution is 85. We do need to check that. So check. We're going to have 2 times 85 minus 4 to the 3/4 is equal to 54 with the question mark. We don't know. What I'm going to do first is cube. Just a little bit easier to cube something. It's going to be a big number. Oh no, I lied. Sorry. Let's subtract first. I'm getting ahead of myself. Honestly, I would probably just type this in my calculator. So hopefully you know how to do that. I can probably make a video on that, but hopefully you know how to do that. So this would be 2 times 81 to the 3/4 equals 54. We're not sure. That's still really messy. I'm going to do, I said cubed first, so I'm going to do the 4th root first to make that number smaller. So this would be 2 times, the 4th root of 81 is 3 because 3 times 3 times 3 times 3 is 81. So when I have that, this is going to be 3 cubed is equal to 54 with a question mark. 3 cubed is 27, which we're familiar with. And this one does check out. So x equals 85 would be a solution. So the solution set would be 85. All right, next problem is a little weird because we have t's on both sides and radicals on both sides. So we want to get rid of this square root. And so we're going to square both sides. Just be careful. You need to square the whole side on the right side instead of squaring the t and the 5. You'll get messed up if you don't. So we're going to be left with t plus 7 equals, And then I'm going to go quickly through this. It's a perfect square, so it's t squared minus 10t plus 25. If you're confused on that, there's probably a previous video that I'll try to link. All right, so now we need to get a 0 on one side so we can solve this. So I'm going to subtract t here from here and subtract 7 from here because those are like terms. And I'm going to get 0 equals t squared minus 11t plus 18. Now you can do a lot of different things here, but this one's very easy to factor. So this would be t times t. 9 times 2 gives me 18 and adds to get 11, and we need a negative 11, so they're both negative. Using the zero product property, I would get t equals 9 and t equals 2. We do need to check both of these to make sure neither are extraneous. And so when I do that, I am left with the square root of 9 plus 7 is equal to 9 minus 5. So that would be the square root of 16 is equal to 4, and that one does check out. Same thing with 2. Square root of 2 plus 7 is equal to 2 minus 5, and I get the square root of 9 is equal to negative 3, and that does not check out. So this one is extraneous, and our only solution would be 9. Now some of you might get confused because negative 3 squared is 9, but we only do the plus or minus with square roots when we're given, or when we're solving a problem. When we're given a square root, we go with the sign that's here. And here they did not give us a negative, it's a positive 9. So this one is not true. All right, next one, fifth root of 2y minus 1 equals fifth root times 10y plus 3. Looks crazy, but when we take the fifth power on both sides, we're just left with a pretty easy problem. 2y minus 1 equals 10y plus 3. Subtract 10y. I'm going to add 1 at the same time. And I'm left with negative 8y is equal to 4. Divide by negative 8. And I'm left with y equals negative 1/2. I do need to check it. And like I said, I'd probably just use my calculator, but we can write it out. So we're going to try the fifth root of 2 times negative 1/2 minus 1 is equal to, with the question mark, the fifth root of 10 times negative 1/2 plus 3. So this would be the fifth root of negative 1 minus 1 is equal to, with the question mark, the fifth root of negative 5 plus 3. And this does check out. We have the fifth root of negative 2 equals the fifth root of negative 2. And we don't even really need to do the fifth root. All right, the last one is an application problem. It says when an object is dropped from a height of 64 feet, the time in seconds it takes to reach a height x in feet is given by t equals 1/4 times the square root of 64 minus x. So we need to find the time to reach the height of 28. So 28 is x. So for part A, I'm going to write small. We're going to have t equals 1/4 times the square root of 64 minus 28. And so when we work this one out, we're going to have 1/4 times the square root of 36, which is equal to 1/4 times 6, or 1.5 seconds. So to answer part A, at 1.5 seconds, the object is 28 feet from the ground. Part B says, what is the height after 1 second? So 1 second would be t. So we're going to have 1 equals 1/4 times the square root of 64 minus x, and we're going to try to find x. Okay, so the first thing we're going to need to do is multiply by 4, so we can move that 1/4. So we're going to be left with 4 equals the square root of 64 minus x. We need to get rid of the square root, so we're going to square both sides. And we're left with 16 equals 64 minus x. Subtract 64. And we are left with negative x equals negative 48. Divide by negative 1. And we are left with x equals 48. and that is feet. Pretty sure that's going to be the correct answer because it's kind of given to us that there won't be extraneous here. But let's go ahead and check it just to be sure. So if we check, we're going to have 1 equals 1/4 times the square root of 64 minus 48. So that would be 1 equals 1/4 times the square root of 16. So 1 equals 1/4 times 4. So that does check out. I'll go ahead and put question marks here, even though we kind of know. So part A, 1.5 seconds. Part B, 48 feet.